Alright, so we're going to kind of refresh our minds on parent functioning and linear graphing. So remember parent functions. Parent functions are a function that has nothing added to it. So this is a horizontal line. That function is f of x of c. Remember the domain is your x value, and how far am I going left and right? So I, on this line, am going at negative infinity to infinity. My range is brackets because it is at whatever that constant is. So this one is at, looks like 1, so you would actually put a 1 inside that bracket. Then I have linear. So I'm going really fast through this because you guys have already had extensive notes on this. This is a line. So remember, to identify that, a line is f of x equals x. This is a linear, we don't call it identity, linear function. Domain, remember, is negative infinity to infinity, and range is negative infinity to infinity. Alright, then we go to absolute value. So that's really what we're going to talk about tomorrow a lot. So one, you're having a paper on just parent functions and graphing absolute values. So then for absolute value is this graph, and remember my parent function is f of x equals absolute value of x. The domain is negative infinity to infinity. The range is 0 to infinity, because remember we start at the bottom, go up, so it starts at 0 and it goes to infinity. And then our last one is a quadratic. So remember, a quadratic is a parabola. So you guys all know that. It's a parabola. And it's f of x equals x squared. So my domain is negative infinity to infinity, and my range is 0 to infinity, because it's at 0 right there. Alright, so alright, so a couple of things. I don't have a square root, a radical parent function, but you guys have that on those other notes. Okay, a linear inequality. So remember, I have less than, greater than, less than or equal to, greater than or equal to. Remember, if I have less than or greater than, it's a dotted line. And if it's less than or equal to, greater than or equal to, it's a solid line. Now remember, it's a solid line because it says equal to. It has that little bar right there telling you that it's equal to, so that should help you. A boundary line. A boundary line is literally this line right here. So if that line is solid, that means those are included in the answer. And then the shading below here, that is also part of your answer. So if the boundary line was dotted, then it would not be part of your answer or your solution set. Then I'm going to give you some little, I hope it's helpful, little guide here to help some of you with shading. So if I have greater than, it's a dotted line, and I would shade above. If I have less than, it's a dotted line, below, shade below. Greater than or equal to, a solid line, above. Less than or equal to, solid line, shade below. Okay, so that's kind of a quick reference if you get confused that you could look at. Okay, so I'm going to turn it over. We're going to work a few problems. So we're just going to graph this line. Remember, it's just a plain old line. So 1, 2, 3, I go down 2 to the right 1, down 2 to the right 1. It says less than or equal to, so that means it's a solid line. Less than, I would shade below, so I'm shading down here. Remember the other way we talked about? I'm crossing the y-axis at 3. Where are all the y's less than 3? They're down here, so that's where you would shade, right? Because I have 0, negative 1. Okay? All right, let's look at the next one. So on the next one, it's not in y-intercept form, so we need to make it that way. So I'm going to multiply all sides by 2. So now I'm going to do my work down here. 9 minus 3y greater than or equal to 12x. I have to get y by itself, so I'm subtracting 9. I get negative 3y greater than or equal to 12x minus 9. I'm dividing by a negative 3. Because I'm dividing by a negative, I have to flip the sign. I get y is less than or equal to negative 4x plus 3. Graph that. 1, 2, 3, down 4, 1, 2, 3, 4 over 1. Down 1, 2, 3, 4 over 1. It is a solid line, so I draw a solid line. And the less than. So this one's tricky sometimes. So still, here's where I'm crossing the y-axis. Where are all the y's that are less than? They're going down here. And less than, we shade below. All right, the last one, because we're not doing the word problems. All right, so the first thing, I have negative 4y less than 4 times 3x minus 5. Well, I'm going to have to distribute that. So I get negative 4y less than 12x minus 20 divided by negative 4, divide by negative 4, divide by negative 4. Y is greater than negative 3x plus 5. So now I'm going to graph that. I go to 5. I go down 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. It's going to be a dotted line. And it says that y is greater than. So greater than is above. And that's it.